Hello, Professor Balaji. This is Chandrakala Jaiswal.
I'm Shruti Salian.
I'm Divya Singh. I'm going to represent the group project. Our project is Amazon Food Review Sentiment Analysis. I'm going to explain the topic as we have divided the topic into subparts. So first, initially we will covering the introduction part, then the problem statement, then I will go through the dataset overview and the data cleaning and the data mining models, process and operators, and then results on training and the test data, and then we will compare the result and then what its application. So first we will cover the text mining as our project is Amazon Fine Food Review. So we are going to interpret the sentiments, that is the sentiment analysis. So how we are going to do, we are going to process the sentiment analysis through the text mining. So we are going through the some of the concepts, that is text processing, features generation, feature selection, and the text mining and the result analysis. As we know that sentiment analysis is used for extracting and identifying the sentiments from the text. It can be done using natural language processing, statistic, or the machine learning methods. So in our case, there are different kinds of data on which we can classify like text, sentence, paragraphs, tweets. For example, if the people use Twitter, so they use the tweets. As we are using the Amazon Fine Food Review, so we are using the text. And now our problem statement is to classify the sentiments of Fine Food Review. We have taken the data from the Kaggle, and there is one attribute, and we have defined a label, that is sentiment, and we have divided the data set into the training data set and the test data set. And we are comparing the performance to two models, decision tree and the naive-bayes classifier. And our purpose of prediction is to classify the sentiments into the positive and the negative review on the basis of the text, on the basis of the Fine Food Review which is given by the people. So for that we need data cleaning and the pre-processing. So as we can see, there is a raw data like ID, product ID, user ID, profile name, and summary and the text. It's just a raw data. So in the process of pre-processing and the data cleaning, as you can see, we have defined one additional column that is called sentiment. We have manually given sentiment as positive and negative for the 6,000 approx 6,000 or the 7,000 data we have divided among our team members, and we have defined manually as positive and the negative for the training data. And we have removed all other columns because it's not required for training the model. And so we are going to process the model through two different data mining models. First is decision tree, second is naive-bayes, and we are using rapid miner tool for building our different models and comparing the different model performance and its accuracy. And in order to import the data set in the rapid miner, we are using sentiments for training the data. And how we are doing through the repository section by clicking on the add data and importing the data set. And then again we are defining the data type into the data type of the attribute, that is polynomial. So in our case, in our project, sentiment was like positive or the negative, so that is why we have defined as a binomial. And then we have saved the data sets. As you can see, we have defined the process flow. This is the complete model structure we have designed for the two models. So I would be explaining one by one. First is retrieving review. What it means means importing the training data. And then we are doing nominal to text. The objective of nominal to text is converting all nominal attributes to the string so that the text column can be converted into the string operator. And then its output is given to the process document. Process document is needed for the cleaning of data. As I would be explaining the process documents later because it consists 3-4 steps. So in the later slides I will explain. Then we are giving the outputs to the set role. The objective of set role is to help in defining the labels. Like for example, in our project, we are defining sentiment as the label. And then we are giving the data into the validation, which will split the data, which will use the split operator for splitting the data into the training and the testing part. And then again we are giving its output to the apply model because it will apply the model either, like in our case we are using naive-bayes and the decision tree, so it will apply both the models. And then again the same process is followed the second one step is followed for the testing of data, which I would be explaining through the output. As I've already explained, that is like retrieve sentiment, which is used for importing the training data. As I have explained, that is read Excel, which is used for importing the data through Excel files also, and process document is used for cleaning the data, and the nominal to text operator converts all nominal attributes into the string attributes. Here we have shown the difference between process document without applying all these techniques like tokenization, filtering, and the stemming. In the next slides, as we can see, there are different operators in under process documents. As is first is tokenization, which will split the data into a sequence of the tokens. Second is filter is stop words, which will remove English stop words like is, a, dal, these kind of words. Third is stemming, which will use for reducing the length. And as we can see, just I wanted to show the difference between the process document without applying tokenization and with applying. As you can see in this slide, it has taken all the text and it has given the total occurrence in the document. It means it is considering the complete text. And in the second slide, as we can see, it is making a document term matrix. As you can see, it is divided into sentiments, positive, negative, like as you can see the words aback, abandon. So these are the words. What it means, 0 is defining these words are not present in the document. And as you can see in the last third row, it has defined 0.170. It means it is present and it has been defined a way. So like it is after processing the document, it is creating term document matrix. And what do you mean by the term frequency? Like it will be like explaining frequency of the term in a particular document. And the inverse document matrix means how informative a word in the document. So it is a kind of providing the weighing of the words. For example, 0.170 for the word ABL, so it has been used number of times in the number of documents. And as I've already explained this part, set role and the validation, so I would be skipping this thing and later I would be running the output part. So as you can, we have run the data on the training. So we have disabled the below models, like below techniques, like, and just we have enabled this retrieve, review, nominal to text, process document, and the set role and the validation. And now we will check its accuracy part also. So NeoBase is a classifier, it is a fastest classifier and it gives better performance. And but in NeoBase classifier, it has a one conditional assumptions also. So in this case, as we can see, accuracy is 61.55, and we have defined different models on the different splits. So first we are considering 50 to 50 splits, and as we can observe, there is a true positive 1673 which are actually positive, and all it has also been predicted as actually positive. And true negative is 325 which are in negative in actual and predicted as negative also. And as you can see, the class recall is 69.10%. so it means recall means giving information about a classifier performance with respect to its false negative. And if like for the positive, if we consider its precision, so it will give the performance of the classifier with respect to its false positive. So now I'm moving to the next slide. As we can see, we are validating the data for the training set. So we are using decision tree operator by navigating into the decision tree tab, and then we are applying this model, and the performance will check the performance of a classifier. Now we are moving to decision tree. We are running all this model on the training. So second is 50-50 data split we have used. Again here accuracy has been increased, that is 82.33%, and the number of true positive has also been increased, that is 2442, and the true negative is 471. And even class recall and the class precision has also been increased. If we consider the second split 60-40, again accuracy has been increased, that is 81.17%. And if we consider 70-30 data split, the accuracy has been increased, that is 81.99%. So we have run naive-Bayes classifier, then the decision tree on the different split. As I want to show the tree structure, for example, the word waste is classified as negative, and you can see as fake word is also has been defined classified as positive. If the value is greater than less than equal to 0.263, so it has been classified as negative. Here in the matrix, we have defined the result comparison. So we have run both the models on the three split. First is 50-50, second is 60-40, third is 70-30. As we can see, decision tree is for the 50-50 is 82.33. For the 60-40, it's 81.17. For the 70-30, it's 81.99. And for the new base, it is 61.55. For the 60-40, it's 62.48. And 70-30 is for 61.77. Now we are running on the test data, and we are running only decision tree for the test data, because as we can see from this slide, decision tree was the best model on the training data. So we have decided the 50-50 split and the decision tree model for running the test data. So again, we have enabled these operators and we are running this model. As we can see, if we double click on the validation operator, we can see decision tree operator, and this training data is given as an input to operator. Then operator would be generating model and it will apply model, and then again it is going to apply on the testing data set. So now this is the output for the testing data set. As you can see here, it is classified as the positive and the negative, and in this matrix we have included the confidence part also, for the positive also, for the negative also. For example, here are the zeros, it means these are the words not present in the documents. And again, we have defined the tree structure for the testing of the data. For example, word thrown has been defined as a negative. For the word fake has been defined negative, and it has been defined according to its, like for example, its value is less than 0.400, so it has been defined as negative. And again, we have considered as 50-50 data splits. Its accuracy is 81.33 because it was performing best on the training data. And here the true positive is 2402, which are actually in positive and also predicted as positive. Same is for negative also, 513. Here the class recall has been also increased, as well as precision, which is the measurement of performance of the classifier with respect to its false negative. So that was the output for our testing data for defining, like for classifying the sentiments as positive or the negative. And then and the last I would like to explain its application. Its benefit is used to process the sentiments in a short time with the help of text mining, and it is also used for in the diagnosis purpose, like in the medical we have used for diagnosis of the patient. Thank you.